So the content today, a little bit of background, as I mentioned. We'll talk a little bit about the building blocks, what we believe is driving in some of the benefits regarding Industry 4.0 implementation. We'll get into MassMEP's growth and innovation model and the strategy and approach that we're taking to unlock that value of 4.0. In addition to that, we'll also be talking about some of the funding options and opportunities we have regarding the expertise that we bring to the table with our partnerships. Our operating model in terms of a mission statement is pretty straightforward. It's bringing growth, innovation, sustainability, and manufacturing profitability to Massachusetts. And by doing that, creating a competitive advantage for our companies. 3 major areas that MassMEP covers is operation excellence, workforce development, and growth and innovation. Today, the focus is going to be on the growth and innovation section, where Rich Sullivan and myself work. We have developed these competitive advantages through many products, programs, and partners. So today, the focus is going to be on Industry 4.0 I4 transformation. There's a video here that we're going to share with that NIST has provided, the National Institute of Standard Technology, that we partner with. We're one of 50 MEPs in the nation. And this is a video that kind of positions us for the next generation, also known as Industry 4.0.
Since the time of the earliest tools and the mastery of fire, technological progress has been an integral part of being human. By utilizing technology, we have surpassed the most efficient and capable life forms on our planet. But in a world of ever-increasing complexity and finite resources, we are now presented with a whole new set of challenges. How will the next industrial revolution change the way we live, and quite possibly, what it means to be human? Throughout history, there have been periods of remarkable innovation. The first industrial revolution created new goods and new jobs through the introduction of manufacturing. The power of water, iron, and steam helped bring manufacturing out of our homes and into a larger world. Cities and opportunities grew. In the second, we forged better materials such as steel, harnessed the power of oil through internal combustion engines, and utilized electricity through generators and transmission lines. We catalyzed manufacturing and expanded what was possible. After the digital revolution, we possess computers so small they can fit in our pockets, and they're 1,000,000 times cheaper and 1,000,000 times more powerful than the best supercomputer only 25 years ago. Connecting through the internet has encouraged an incredible library of knowledge, setting the stage for the greatest revolution yet. So what is the fourth industrial revolution? Industry 4.0 involves a range of new technologies that are fusing the physical, digital, and biological worlds and impacting all disciplines, economies, and industries. Central to this revolution are emerging technology breakthroughs in areas such as robotics, artificial intelligence, the Internet of Things, autonomous vehicles, nanotechnology, and 3D printing. These technologies can improve lives, create new jobs, make goods cheaper and better, and impact the world in ways we have yet to imagine. While it's remarkable to see the current trends, it's important to remember that technological progress is not simply guaranteed. It requires people to make it happen. This is your opportunity to get involved. This revolution does not happen without your help. Now is the time to be imagining. Now is the time to be creating. Now is the time to be a manufacturer.
Discover how the MEP National Network helps manufacturers. Visit the website below or contact your local MEP center at 1-800-MEP-4MFG.
Yes. So I think that that alone really summarizes the opportunities and the excitement around this next generation of connectivity and digital. computerization as well as cyber physical systems. So as we look at the first generation through the fourth and how things have shifted and changed, it's amazing how far we've come just in 30 plus years. Next slide, please. So I was at a NIST conference back maybe September or so, well, a year ago, it seems like. And a NIST person asked me, what's your definition? Because it's kind of all over the map. And the way I look at it, it's a journey of continued improvement. I mean, if we look back, a lot of us went through Lean, we went through Six Sigma, Lean Six Sigma, quality systems, SPC. These advanced technologies in the building blocks of 4.0 fits the realm of continued improvement around enhancing the processes, integrating information, and making companies more competitive, and providing that advantage through those methodologies. And 4 of them you're going to hear about today. So it's a continued journey of improvement. As you look at the building blocks, and this is a standardization of the building blocks of Industry 4.0, we'll be talking about 4 of them. Although there's a few others that we have in our toolkit at MassMEP that are provided. I'll share with you the ones we're going to talk about in a second. But what does it mean? It means smart machines, real-time monitoring, evolving workforce, an agile workforce, an educated workforce, robots, cobots, business intelligence, and I'll also add business strategy. I think that's the first piece of developing Industry 4.0 roadmap, and I'll talk about the roadmap in a minute, but business strategy plays a key role in the introduction of Industry 4.0. These texts, I'm just gonna, that's okay. Business drivers, we can go there. So there's quite a few business drivers. We could build this out, Rich. The human capital side is as we start to develop a skilled workforce is as we change the environments in our factories. Regulations, compliance, there's quite a bit of that coming down. And a lot of it around compliance, around defense industry, medical industries, cybersecurity efforts, technologies change, and the innovation is so creative now, and it is being seen across the board. Global economy, that the competitive edge, the expectations for higher profits, a better optimized organization when it comes to efficiencies are going to be key drivers in the future as they are today, but as they continue, this is where the skills and the expertise of these new partners in Industry 4.0 will be playing a major role. The benefits, I think, are pretty straightforward. Productivity through optimization, automation, real-time data to make quicker real-time decisions in your factories, improve business continuity through predictive maintenance, understanding what's going to happen before it happens, and to be able to put those predictive maintenance programs in place on equipment. Higher quality products with the tighter controls. So earlier understanding of variation or yield issues in your factory will save money in the long run. So having the types of systems that measure from sensors to data collection elements will help put those tighter process controls in place. Working conditions are going to be superior for long-term sustainability of workforce that want to be part of a clean environment, personalization of opportunities that are in customer loyalty. These are when companies come into your factory and they see the types of automation, the type of work environments that are being provided to employees are going to make a big difference. So businesses will ultimately become smarter and more efficient over time by implementing 1, 2, 3, or 4 of the types of building blocks that are going to be available to you, as well as you'll learn a little bit more today on those. Our plan, MassMEP, is basically providing these 4.0 solutions through partners and industry experts. These industry experts are not necessarily coming right out of MassMEP. We have core technologies, core experts, but some of the solutions that we're going to provide will be partnering with some of the experts that you'll hear from today. Also, we are uncovering an enormous amount of funding opportunities through various resources. There's National Institute of Standard Technology grants, there's DoD OEA grants, there's workforce development grants that are going to continue to support and help our clients in Massachusetts continue to develop and grow and add value to their businesses. Today, we have grants in all of those areas of the business. So it's not just a one-stop shop in terms of a fit for funding, but there are many options that we have to help companies like yourself move into Industry 4.0 solutions. A little bit of how MassMEP is going to conduct its strategy and approach of unlocking the value is around education, assessment, strategy, foundation, and implementation. So on the education part, we are building out videos. We do a lot of presentations. These types of webinars hopefully will help and give an understanding of what's available. I think that's the first step. Understanding the assessment where our partners can go in and understand specific areas, identify the areas of opportunities, develop gap analysis, prepare return on investment strategies that will help prepare budgetary and develop roadmaps. The foundation, we believe, is a strong IT infrastructure, cybersecurity programs, business strategies. And then the implementation. This is where we can come in with funding from various areas to help deliver the education and training to the workforce to move forward with Industry 4.0 solutions. To give you an idea of the partner capabilities we have, we're going to talk about 4 of them today. But we do have a strong, comprehensive cybersecurity solution base between CyberSaint for CMMC and 800-171 DFAR programs, Exalytic for ISO 27001 certifications. We have Notch Above Consultant that can help in the Industry 4.0 implementation and readiness or preparation of the IT systems and understanding the needs, as well as the future of their IT requirements. We have Spinnaker, who you'll hear from today, the next 4. I will provide a good overview of the business strategy of Industry 4.0, machine metrics, the Internet of Things, data collection, optimization of shop floor operation efficiencies, Design Point, who partners with Markforged on additive manufacturing, design for 3D, identifying high value opportunities, as well as education and training, and same with Access New England, robotics training, implementation of hardware and software solutions. All of these, as you can see on the right, MassMEP has current contracts with, and we have funding programs. This took us a while, but all 7 of these partners with their capabilities are currently funded through express grants, general grants, and soon to have combination of DoD, NIST funding for education and training. So we're well positioned to move to the next step of implementation and training and education for our clients who wish to explore the opportunities. And we'll talk about that with the consortium and some of the funding and partnerships that we could develop. Next slide. Okay. So that's what I have today. I think more important is going to be listening to the next level of groups, the next 4 groups, as I mentioned. And I'm hoping that everyone gets something out of this. And there'll be a few surveys, questionnaires coming through at times that Christy will provide as she starts to gather some analytics and data that'll help us with determining what the needs are of the future clients in Massachusetts. So thank you very much. Hope you got a little something out of it. And we hope to hear a few questions from everyone. Thank you.
Thanks, Tom. We appreciate it. So as you can see, we threw a poll up there for you in the audience. If you wouldn't mind answering the questions for us, it gives us a nice little gauge on everybody that's in here today and what they're looking for their industry 4.0, where you're interested in. You can check all that apply. So please pick those out that are the most important to you. Great. Thank you for the responses. It's a good response. So I'm going to end the poll, and I'm going to share the results with everyone. Let me share the results so everybody can kind of see. So we're going to move into our next speaker. We have Mark Roth with us, and we have Greg Bauer as well. I think Mark is going to be running the presentation. By the looks of it, Mark has some really great lighting where he is today. It looks like you're outside there, Mark. So let's... Perfect. Oh, Greg is as well. These guys are usually they're outside when they do their presentation. They've got some great internet bandwidth wherever they are. So we wish we could have that. But yeah, so I'd like to introduce Mark Roth, who's the managing director with Spinnaker Venture Partners, and Greg Bauer, also a managing director. And so we're going to turn it over, and Mark, you should be able to grab a hold and off you go.
Okay, let's see. So
you're all set.
You see it?
Looks
okay.
good.
Well, great, guys. Yeah, this is Mark Roth. I'm actually just south of Boston, as everybody, working from home on my back deck in Hingham. So, and Greg Bauer, my partner, is actually in Medellin, Colombia, but he was fortunately able to join in on this at this point too. So, what we want to talk to you really about is the first step in all this, which we think is really developing a proper strategy. And especially now in what we're calling the new normal, some people might say what's going to happen post-pandemic, but let's just call it the new normal as things may change. And what we're interested in really is how we can think and act differently about Industry 4.0 as it relates to creating value for our businesses and driving growth. Not just operational efficiency, but doing things that are operationally efficient that can then translate into higher margins, but also into driving growth in revenue, and therefore create greater value in the business, both for our businesses and for our customers' businesses as we all participate in the supply chain. So as we all know, Industry 4.0 here is made up of a whole number of identified, let's call them buckets of technology. Whether it has to do with cybersecurity because we want to connect to our edge devices to take the data around, or we want to use advanced robotics and 3D printing, which you're going to hear a lot today about as well. These are all what we would call point solutions. And the idea is, which is the one you should use? So what we really want to do is understand, is not have it being about technology looking for a problem to solve, but really be able to articulate well the problems that we need to solve, and then schedule the right technology investments at the right time so that we can achieve Industry 4.0 concepts effectively. And to do that, we want to do it in the context of how we create value and derive new sources of revenue while delivering operational efficiency. So to the extent that we know, we can use things like augmented reality, and we see ThingWorx and people like that trying to do that, you know, or use extended sensors for monitoring and digitizing that out, or even advanced robotic applications within our own operations. As we do that, we should understand, are we gaining information? Are we gaining up some insights? Are we developing business models that at the same time can be extended to our customers, in which we can create new lines of revenue for our business at the same time that we're creating efficiencies? So a classic one would be service efficiency, especially now in the current circumstances. Industry 4.0, remote connectivity, analytics, predictive diagnostics, all would make a more efficient service model that then you can charge extra money for that response to your customers, as an example. So the question really we want to ask is your business ready yet? Do you have a proper strategy before you start investing in Industry 4.0 activities? When you look at the scenarios, why this is important now, especially relative to this new normal, as it relates to Industry 4.0, we think that there's really two really important potential outcomes, neither of which we really understand, we really know today, which is going to be the outcome. One is where all of a sudden we move to, or continue to move in a world which is trying to collaborate and coordinate globally as we go forward. Or it might be where we really want to focus on national self-reliance. And depending on which way this goes, or to what extent it goes between both of these poles, let's call them, you can see where it's really going to have a lot of impact on how supply chains might be restructured. In any case, I think we all could agree they're probably going to be restructured. So whether it's going to be, how do I de-risk myself from just being dependent on China? And that makes a lot of opportunity for all of us on this call potentially. Or if we really want to have national self-reliance, and then we're seeing like, how can I structure my supply chain so it's all domestic? Again, a lot of opportunities for us to possibly participate in as we go forward. So I think our view is it's an optimistic view of the future if we get ready now. So some of the questions we really think we ought to ask ourselves is, how can we respond to these opportunities and that we get from Industry 4.0, as well as the challenges? Sometimes things like security, getting the edge data in, getting connected, those might be challenges, but they also represent big opportunities. What capabilities might we need to create in our business to leverage the connected economy? Industry 4.0 is all about being connected. It's all about digital transformation. What new market segments and geographies may we have an opportunity to participate in, especially now? That's an important question to ask. And how might we better take the capabilities we have and leverage them better? Again, if we can understand what's underneath there, understand what the information is being generated within our environment, we might be able to use that information to get better insights in order to create value and capacity in our business that we didn't know we had before. And so therefore, ultimately, how should we invest in Industry 4.0 and where are we going to get those opportunities? So we want to answer those questions as a strategic front end. And we have a program here with MEP that allows you to participate with us to actually quickly develop such a roadmap for yourself. So how do we do that? How do we find this opportunity? How do we develop this strategy? And what kind of tools do we need to go forward to do that? Well, what we really want to point out to you right now is it's about data. Your businesses, your equipment, if you're machine builders, your machines, your operations, your enterprise has an enormous amount of data. Some of that data is not yet unlocked from the factory floor, from the operational point of view, maybe even caught up within your accounting systems relative to the kinds of revenues and the cost of that revenue. It's all this data is caught up in your enterprise, and we need to take advantage of the data. We see the core essence of Industry 4.0 coming from what can we do with the data to turn it into information, to gain the insights that we need to create value for higher profit margins, and to create value with new sources of revenue for our business, and therefore create greater enterprise value. So to develop this roadmap for deployment, and I'm going to describe to you now a framework that we use that is supported in our MEP program to come up with this roadmap development. So to be prepared with what comes next, we want to do this in a structured way. So how do we do that? First and foremost, we want to look at the historical and future sources of revenue in your business. It may seem different. Normally, people will talk to you about, let's analyze the cost. Let's do a Kaizen. Let's find out those point places where we can create operational efficiency. But what we have learned in practicing this for a long time is if we look at the revenue line of the business and decompose it in a new way, it tells a great deal, it tells a very interesting story and opens up really interesting opportunities as to where we should act on our business from an operational perspective to enhance it, both in terms of providing greater margins, but also in being able to drive new sources of revenue. So first and foremost is this base retention. I'm going to get into these in a minute. Share gain and market position. Once we understand the diagnostic of how to look at really what would be the last few years of revenue of the business and what it tells us in a story, it's going to allow us to really create a nice portfolio of investment opportunities in Industry 4.0. that you would want to consider and understand the economic business case for making those. And then lastly, schedule those into some sort of a multi-year roadmap for implementation and execution. So to create a real structure and a discipline around the diagnostic, but then also around how to structure a plan to go forward as a strategy. So what are these things really about? I'll do this very fast, and if you're really interested in this, you'll be able to get these slides, and we'll be available anytime to talk to anybody about this. Base retention is really around how to preserve the current business, the current revenue that you have with the current customers, especially in this changing time. This is a very, very volatile moment because a lot of people are thinking that this is, you know, business is weird now anyway. Things may be up, things may be down, things may be growing, but it's a good time to rethink who is going to be my supplier. So when you think about your customers, they may be thinking that. Secondly, though, share gain, there's a lot of opportunity for gain because unfortunately the situation has created some competitors have become weaker while others are become stronger. And if you're in that position, you may be in a very powerful place to be able to gain share or move into new geographies. Market positioning in the case of this new normal really is going to be, how are we going to reorganize those supply chains and where should we show up in order to participate in addition to where we play today geographically. Market adjacencies are, can we take what we know how to do to new applications or adjacent applications because our expertise will be used well there and gives us another new growth strategy. And then, so that's what the base retention is to decompose your revenue line into these kinds of things, and based on that, to build a plan that would respond to that. But what you might have to ask is, where am I, even if I do this, where am I going to get the capital and the resources in order to execute this strategy? That's really tough. So for that, we have what we call the resource framework. It's to look at your past performance and to look at the future potential of what we just talked about, and to create activated capacity by really looking for these efficiencies. So when we get efficiencies from using data properly to create information, to get the insights, what you're going to probably be able to do is, you'll see from the very next speaker, from machine metrics, you will be able to open up capacity in your business. You'll be able to open up available resources in your business that you don't think you have today by being able to understand really how they work and how they maybe could work better. Or you can understand things you're investing in because you've done it that way for a long time that maybe don't need to be done that way anymore, and you can release some resources that are focused on those activities and concentrate them on new activities related to Industry 4.0. So we believe that within everybody's business, there's already the available capacity and capital to address a 4.0 strategy if you approach it correctly and you really unlock the value inside the data of your business. When you put these together, we come up what we call the integrated growth framework. It has a lot of questions you can answer, which would create the strategy. And that would be really the result of what you do. Now, to give you that's sort of the end of the end of really what we would do, conduct this as a program with MEP. We call the integrated growth framework, I believe. But if you think about it, just to close up here, if we just look at, say, the healthcare ecosystem, and if you look at your own ecosystem in your own business, you might be surprised as to how spread out it is and how connected it is and how many places it touches and where you basically find yourself in this ecosystem, would tell you where we can create the relationships and where we can use Industry 4.0 to create value, to create better services, to turn some of our the products that we sell into a service-based line of revenue that complements it, for instance. Simple example, again, that we all can understand in healthcare is just even around the hospital bed, and how a hospital bed as a piece of equipment in the past now is really the hub of the information around the patient. So with that thinking, what would happen from this? Well, just as a case, in a typical case, we've been able to show that over a 3 to 5 year period, we've been able to help people to figure out how to double their revenue, and at the same time, get 50% more margin on that revenue as they grew their business. So that's where we're at. We're saying, let's think and act differently about Industry 4.0. Let's figure out how to create value while we look for operational efficiencies. At the same time that we create growth in the business to create value. And we're going to do that primarily by understanding what kind of information and data can be drawn out of your business to create that value. And with that, I will close, because I think the discussion by the next speakers is very relevant to how we would move forward. Thank you.
Thank you, Mark. Great presentation. And we're gonna keep on moving right into our next presenter. So I'll throw this up here. Everybody can kind of see. Actually, Graham is quick on the draw today. So this is our next speaker this morning is Graham Immerman. He is the Vice President of Marketing with Machine Metrics. So go ahead, Graham, and you can jump right on in.
Well, thanks for having me. Hopefully everybody can see my screen, and really insightful comments from Mark there, as well as from Tom and MassMEP. Really appreciate it. My name is Graham Immerman, and I am the Vice President of Marketing at Machine Metrics. Something to note before I start my presentation: I started my career during the heart of marketing's early digital transformation, where the advent of the internet and social media changed the way that people and systems and things interacted with one another forever. My excitement to join Machine Metrics on their journey really stemmed from the fact that today is that internet moment for manufacturing. While manufacturing as an industry, and virtually any other industry in the world, it has been notoriously slow to adopt that digital mindset that other industries like agriculture, banking, healthcare, or even marketing has. So it is undeniable that the current impact of economic conditions and the world will undeniably permeate numerous areas of manufacturing. And it has truly never been more important in this time to harness the power of data to inform ourselves, our businesses, and drive decisions that will reshape and rebuild a more sustainable, resilient industry of the future. So, that's a little bit of my precursor to the presentation. But before I get started, I figure for some context, it might make sense to tell you guys a bit about what we're doing at Machine Metrics. So Machine Metrics is an industrial IoT platform designed for manufacturing. Our objective has been to accelerate use cases for industrial digital transformation by providing an intuitive, easy to use, and flexible platform to easily collect and transform data from any piece of manufacturing equipment into powerful, actionable applications that help manufacturers or anybody within the manufacturing lifecycle reduce downtime related to manufacturing equipment, optimize machining capacity, drive increased throughput and profitability for factories. Right now, we do have hundreds of manufacturers have connected thousands of machines to Machine Metrics across global factories. And our platform is enabling these companies to harness their data from their manufacturing equipment to deliver improvements in machining performance, productivity, increase capacity utilization, and to Mark's point, transform the way that they do business all around optimizing the operations of these machines. So industrial IoT initiatives drive significant manufacturing improvement by providing, real-time and historical insights, and even some, predictive insights into what's actually happening on the shop floor and what can be done better. But in many manufacturing facilities, although equipment produces all this data, it lacks connection to any sort of data collection, visualization, or frankly, it lacks the ability to drive action. We found, in fact, that most digital transformation initiatives are stifled by a simple inability to get usable data from manufacturing equipment. I use that word usable intently because it's not just about getting data, it's about enabling a transformation of that data into a usable format that can be immediately taken action on to drive improvement. Because of this status quo, operating on gut instinct leads to tremendous inefficiencies that affect every component of a manufacturer and the manufacturing life cycle's operation, and leads to production losses, significant downtime, and an inability to drive more revenue consistently over time. Machine Metrics can tell you this fact that you see on the screen today because, as I said, we aggregate data across thousands of machines all over the world. And Top Shop's reports last year indicated that manufacturers assume that their average machine utilization rate is closer to 65, 75%, and it's not. It's actually closer to about 25%. And understanding this number, right, helps drive every facet of your continuous improvement strategy. From, do I need to buy more equipment? Should I be hiring more people? Should I be staying open longer? Where does this number come from, right? And a wise person told me, well, if I, can you sit down for a bit? Because if I were to tell you all the reasons why we're using our equipment 25%, I could count you 100 reasons, 200 reasons, right? And that's your continuous improvement strategy, right? Is to identify which ones are most effective and to your business and how you can improve them. So with that said, we've also found that the second reason why digital transformations tend to be stifled is by a failure rate of implementations. And this is a stat that comes directly from Cisco themselves. It's I guess an IoT provider, which is 70%, 76% of IoT implementations fail. And we believe one of the top reasons why that is just due to an inability to create rapid value on the shop floor. And because that rapid value can't be realized and understood, projects just don't get off the ground, and the value is not realized of implementation. So this leads to that current state of manufacturing, where legacy business models have diminishing returns, data is siloed in various places, that high failure rate of IoT projects, and just inefficiencies that affect every component of the business. So we set out specifically to solve that problem. So the foundation of our platform is built upon that initial statement that I made around making sure that data is usable. So the automated capture and transformation of machine data, so it can be immediately harnessed to drive value for a factory or anybody within the manufacturing lifecycle. Machine Metrics provides an edge platform that has plug-and-play universal machine connectivity to PLCs, digital and analog I/O sensors. So there's no machine on the shop floor essentially that can't be connected to our platform. Whether it's a modern piece of equipment or we've connected machines as old as World War I era machines. So I think it's important to note where when it makes sense to invest in new equipment, and when older equipment is working just fine, and having data helps you make those decisions. But our ability to transform machine data into standard structures across all those different pieces of equipment enables consumable, actionable machine data insights in a matter of minutes. That data, right, is then instantly and securely streamed to our cloud platform via Ethernet, Wi-Fi, or cellular. That is built specifically to ingest data from manufacturing equipment, and this delivers instant analytics and insights in a matter of minutes, hours, including machine performance, condition monitoring, and reporting, as well as extensibility to all of your other shop floor systems that require machine data to continuously improve. Lastly, to make data actionable, we deliver use cases that drive immediate actionability, including real-time dashboards, historical reporting, rules-based workflows, text email notifications that deliver optimized processes to factory workers. But you can also, we know that similar to when you buy a computer and it comes with, maybe you buy a Mac computer, it comes with, your Keynote and your Safari and all these apps, you can use it immediately. We know that you're going to want to add your own applications, right? And you're going to want to add your own customization. So within the Machine Metrics platform, you can easily build your own apps, and you can seamlessly connect that data with your current shop floor systems like ERP, CMMS, quality management, business intelligence, to integrate that data across your digital factory. So, our value propositions that we found tend to take forms in production monitoring, which is the ability to monitor real-time analytics on your machines, including your utilization, your downtime, OEE, identify bottlenecks to apply your continuous improvements. We call this kind of the descriptive phase of analytics. As you move forward, you may want to understand more why machines are down, not just related to inefficiencies in process, but actually related to the health and maintenance of those machines. And that has its own analytics journey. You start today, maybe you're doing just like reactive maintenance. Well, when the machine breaks, we fix it, right? But the next phase of that journey would be to, use a calendar-based maintenance program, right? But then the next phase of that journey would be to leverage a usage-based maintenance program, and then a condition-based maintenance program, and then eventually a predictive maintenance program. So, that's the journey that we see in a number of facets on the shop floor, and Machine Metrics provides a solution that helps a company take that journey wherever that they might be, including that predictive maintenance aspect. And something that we've uniquely been able to offer for our customers is access to high fidelity data from manufacturing equipment, which is essentially like the discovery of HD for TV, which is something we've just released to our customers, which allows us to a new visibility into data that's never really existed before. And we're currently predicting certain machine failures at our customers at 99% statistical significance, up to 45 minutes before they fail. So it's really, really amazing stuff. But essentially with our platform, manufacturers can now really significantly expedite that time to value for Industry 4.0 implementations, put that data to work immediately, and provide a foundation for scaling that data across 1 plant, 5 plants, 100 plants, while prioritizing their internal resources towards what they do best, which is make the best things in the world. Regarding a program that we've put together with MassMEP, how do we help manufacturers realize this, right? And how do you get a blood test? How do you step on the scale and see, hey, here's where those problems are. Here's why we should believe in this technology. Within our training program that we put together, we're providing our platform and training workshops to demonstrate how easy it actually could be to connect, collect, transform, analyze, and take action on shop floor equipment data. So within the training, we're gonna help organize your company to begin answering questions like, well, what's happening today and why? The training will really focus on using our platform, understanding your machine utilization and capacity, understanding downtime, validating job standards, escalating data to the right person using automated notifications. The program is actually quite simple, and it has really 4 steps. Step 1, connect machines. Within the program, we enable up to anywhere from 5 to 20 pieces of discrete manufacturing equipment to be connected for a multi-month period. There's no cost to use this system. There's some parameters around which machines, but that's more just to make it easy. And this is to allow us to have the connectivity to collect data, which is step 2. Within that second phase, our focus is to baseline machine utilization. Robust data will be collected from machines in real time, so we can understand and start analyzing that data in step 4. Step 4, we work with the training and guidance of our customer success team to learn the foundation of how to drive decision-making with data, leveraging dashboarding, reports, notifications. We're looking for inefficiencies within the data that can be easily noticed. And then lastly, most importantly, just understanding where your bottlenecks are and it is just the first step. But to realize the value of those insights, you need to transform them into action. So we will work with your team to deliver optimized processes on the shop floor, delivering the right information to the right people at the right time through automated notifications, email, text alerts. So that data can really start being made actionable and realized on the shop floor. These are some of the objectives of the training program, including that baselining and benchmarking of your machine utilization, identifying bottlenecks, optimizing your job standards, and really taking your shop floor from a reactive one to a proactive one. Just a quick case study that I'll show you about what this program looked like when we do it with our customers. This is the way we start when we work with any customer machine metrics. We try to identify connect machines, which happen within a matter of days, and then identify the problems. And what we found at this manufacturer, for instance, was that their operators were spending inordinate amounts of time roaming the shop floor looking for things that they needed to operate their manufacturing equipment. And that led to a frankly absurd amount of downtime related to setting up machines and changing over equipment and tools and so on and so forth. So the solution was actually quite simple. Number one, once that became immediately apparent through machine metrics, setting up systems to change that process, kitting tools at the machine before the day started, optimizing scheduling procedures, creating a feeding circle for their lathes, new training processes to integrate operators with their processes for setting up and changeovers, and the results were staggering. They saw an immediate 30% increase in their OEE over the first 6 months. They took that 14,000 hours of setup and reduced it to 1,000. And across those 60 machines, and now they're connected across 12 factories, they saw a $4.5 million increase in their capacity on just that first implementation. So, to the point of everybody else in the presentation, these implementations have just remarkable value, and it's ongoing. So that's the program we put together, and we're excited to work with anybody who's interested on that. Thanks for, I guess I'm opening up to questions now. That's correct.
Yeah, actually, Graham, we don't have any questions as of right now, but if anybody did have any, we actually have kind of been answering them on the fly as well. So I'm going to be honest if there has been any popped up, but we're going to try and do a Q&A at the end to make sure that we get all the questions answered. Thank you for presenting. Graham has a super snazzy presentation deck. We obviously, us marketing people, are partial, and we love the snazzy marketing deck. So content is great as well, Graham, obviously, but we like the pretty packaging, as we like to say in marketing, right? So we're gonna jump right into our next speaker, and we have Andrew Garczyk, and it's only spelled with a K. Please don't put a C in there. I have done that a couple times, and he's called me on it. But
there's no chance it's not going to happen again.
Right?
No
Andrew is an application engineer with Design Point, so we're gonna once he goes into slideshow mode, and he's gonna switch over his settings so everybody can see just his presentation. He's all set, and the floor is yours, Andrew.
Thank you, Haley. Thank you, MassMEP. I really appreciate the opportunity to be speaking to you guys today. I've got some really cool stuff to share with you, so I think you're really going to like it. Here's the plan. First, I'm just going to give a very quick introduction. Who am I? Who is Design Point? Then we're going to talk about 3D printing and where it fits into manufacturing, where we were, where we are, where we're going, and why you should care. After that, I want to cover a couple industrial 3D printing technologies that are newer, that are actually being used in the field today by thousands of companies to get a competitive advantage. With no further ado, I'm going to jump right in here. So that's me. I'm Andrew Garczyk. I'm an application engineer with Design Point for about 3 years. Design Point is a growth advisory firm, and we work with manufacturers to help solve problems and bottlenecks by providing hardware, mostly 3D printers and scanners, software. We've been a SolidWorks reseller for over 25 years, and other engineering services. So me personally, I manage our metal and composite 3D printing facility, which you can see in the picture there. And I have a lot of hands-on experience with the machines and also working with manufacturers to implement the technology. So who remembers headlines like this? 3D printing is going to change the world, right? There was a lot of hype about 10 years ago, a lot of hope. I remember one friend telling me, when you order off of Amazon, they're not going to have to send you a package anymore. You're just going to simply download the file and you're going to print your new coffee mug or whatever it is in your house. Another friend told me you're not going to have to get an organ donor. They're going to be able to 3D print a heart for a heart transplant out of your own genetic material. And it goes on and on, right? I'm sure you've heard many of these things too. But what did we really get? Well, the reality we got was a bunch of Yoda heads, right? The printers that were out back then, they were, more or less toy makers. They were low resolution, the low accuracy, and as a nerd, Yoda heads are very cool, but they're not very functional for a lot of things. Some folks were able to find some good value in prototyping, but nothing very functional like tooling and fixturing or end use parts or anything like that. So what happened? Well, to take a look at where we were, where we are, where we're going, I like to use the Gartner hype cycle. So this covers adoption of emerging technologies. You've got people's expectations on the left versus time on the lower axis. And we're going to start on the left side of the blue line and work our way to the right. So starts off with an innovation or a trigger, right? 3D printing is invented. Then the next stage is peak expectations, right? Expectations go through the roof. You're going to be 3D printing flying cars and heart transplants and all that. But then what happens? Yoda heads, right? So expectations then take a huge drop and it goes into the next phase, which is disillusionment. And I'm kind of being a little jokey with the Yoda head thing, but this could have been very serious for manufacturers. Maybe somebody bought a $50,000 machine thinking, I'm going to get ahead of the curve here. And then over time, they learn they can't really make the fixtures and the tooling they need. So they said, oh man, this 3D printing thing isn't what I thought it was. It's not for me. I don't want anything to do with it, right? But then what happens? You move into the next phase where expectations start to rise again, which is called the plateau of productivity. So what happens here? Why do expectations start to rise? It's because technologies are coming out that are starting to meet the expectations that people have. So, we're not, 3D printing hearts, but if you Google 3D printing human tissue, you're going to find some stuff out there where they are just starting to 3D print human tissue. Now we've got technologies like the couple that I'm going to cover in a few minutes, where you can print over 20 times stronger materials. So now you can make tooling and fixturing and end use parts and replacement parts. There's also a number of metal 3D printing technologies out there. There's large format 3D printers. The University of Maine has a 60-foot 3D printer where they print boats in one print. So it's pretty cool. So at this stage, a lot of folks are finding, where we are today, a lot of folks are finding ways to adopt this technology, and they're getting a competitive advantage over the competition. The next phase you move into is mainstream, all the way on the right. Now, this is where people know that 3D printing is going to be a manufacturing tool. They say, 3D printing, what are you kidding me? My shoes are 3D printed. My hair is 3D printed. Why wouldn't anybody think that you need 3D printing in manufacturing? Of course you need it. And at that point, it's now a competitive necessity. And those who have not adopted this are going to be left behind by the competition. So why should you care about 3D printing in manufacturing? Well, from my own personal experience at Design Point, we've worked with multiple hundreds of companies to implement industrial 3D printing technology to great benefit. And here's some of the benefits. We've seen folks really transform their business. Certainly, if you're making parts less expensive and you're cutting down lead times, you're going to see lower production costs. You're going to see an improving profitability. I love the one in the top middle there, free up machinist talent. Most people don't realize, and I've come to learn this from talking to manufacturers for the last few years, that machinists are kind of a dying breed. There's simply more exiting the field than there are new ones coming in that are highly skilled. So most companies I've talked to, they have just enough machinist talent, or some of them are actually a little bit understaffed. So they've got their guys very busy. So with 3D printing, what that allows you to do is transfer some of that work from the machinist to the engineering side, where your engineers can now, let's say you have kind of a complicated fixture with complex geometry. Well, now your engineer can design it. They can hit print. You know, printing is lights out, right? Then, you know, at night, over the weekend. So then the next day, you've got your fixture, and all the time, your very needed machinist talent has been working on more important things. Mainly, what I've seen is they like to keep machinists focused on production, and the engineers focused on creating tooling and fixturing. On the bottom left there, you've got shorter product development cycles, so rapid prototyping, right? In the past, like I mentioned, this is where folks got the most bang for their buck with 3D printing and manufacturing. Nowadays, you can even do better with that. You can make functional prototypes, right? Because now you have much stronger materials. But nowadays, where Design Point has seen by far the most benefit from 3D printing and manufacturing is this next one, faster changeover and production scaling. I think that alludes to tooling and fixturing, and folks who have been able to optimize their tooling and fixturing strategy have been able to see major benefits. So that's one of the first places that we look. Reducing inventory overhead. Some folks, this could be a game changer. Some folks, they don't care. But I've been in a facility where I've seen 5 rows of 20-foot shelves, all filled with tooling. They're scared to throw anything out because as soon as they throw it out, they're going to need it, and each piece may cost thousands of dollars. And it's a high cost to keep that inventory and to have somebody to organize it. So now with 3D printing, you can have a digital inventory. Because it only takes a day or maybe 2 days if it's a big part to print a part, you no longer have to have all this inventory. You're no longer waiting 6 weeks potentially for a new piece of tooling. You're getting it next day, so you can just print a part as you need it. Or some folks will just print one as backup, and as they use the backup piece, then they'll print a new one as backup. All right, poll time. I'm really curious to see how you folks feel about metal 3D printing. Will your company adopt metal additive manufacturing in the future? Number 1, yes, as soon as possible. We're all about it. 2, we would like to, but not too sure. 3, probably not, but maybe someday. And 4, no, it's just not for us. It's never going to be for us. So curious to see results. I'll keep moving, but when we get the results in, we'll circle back to that. Okay, so the course that we're offering with MassMEP on additive manufacturing, we're going to cover intro to additive. We're going to cover design for additive, you know, designing around the technology. We're going to cover identifying applications within your own facility. But today I wanted to cover something that is a little bit more fun and interesting, which will also be covered in the course. But I want to cover a couple technologies that are being used today by thousands of companies for a great benefit. So the first one is called CFF, that stands for Continuous Filament Fabrication. So with this technology, you print plastic that's actually already reinforced with chopped carbon fiber, and then you lay into it a continuous strand of fiber. Continuous carbon fiber for strength potentially, Kevlar for durability and impact resistance, perhaps high temperature fiberglass for high temperature applications like molds. So basically the idea here is you can customize your material for your specific application. So you're going to lay in these continuous strands of fiber, which is putting an internal supporting structure into the part, right? Think about your body. You wouldn't be much without your skeleton, right? You'd fall on the floor. But also you wouldn't be much without your muscles either, right? So the combination of the two creates a composite that is better than either one of them on their own. Think about it like rebar, right, in concrete. You're putting a long strand of a different material into a matrix material, the concrete, in order to increase the strength many, many fold. So that's what you're doing here. You're printing in plastic, but you're putting continuous fiber in as an internal supporting structure. And the biggest reason, I mean, there's other, I mentioned a few, but the biggest reason folks are using this today is unmatched strength. So this is a yield strength chart. On the bottom, those lines there are the regular 3D printed materials you're seeing today. PLA, ABS, you know, nylon. And then when you add continuous fibers, right, like the carbon, Kevlar, high temperature fiberglass, you're seeing those lines jump up to these colored lines up here, and the strength is just jumping off the chart. That's when the magic happens. So with Kevlar fiberglass and high temperature fiberglass, you're seeing about 10 times the strength versus the regular 3D printed materials. And then there's carbon fiber, which is everybody's favorite. You're seeing over 24 times the strength. And if I were to put a line on here for 6061 aluminum, it would be right where this carbon fiber line is. They're just about the same slope. So what does that mean? You're printing a composite that is actually metal strength. You're printing parts that are potentially more durable, but the whole idea is here you're optimizing for performance. You're putting that fiber in where you want it, how you want it, very strategically to get the properties out of your part specifically for each application. Cool stuff. I've seen a lot of this. This is between this technology and the next one I'm about to present, there's over 10,000 printers in the field. And I'm guessing that's probably around 7,000 companies that are already using this as we speak. Their printers are humming right now. Oh, so the next slide here is using that technology. This is a chain link that's reinforced with continuous carbon fiber to make it extra strong. So we're seeing 21,000 pounds, 21,500. Where's it going to go? Perhaps 22,000 pounds? Oh, there it goes. A little over 22,000 pounds, right? So you can see there the strength is really quite incredible. Well, looks like I may have lost the ability to go to the next slide. Oh, there we go. Okay. So the next technology I want to cover is called ATOM. This stands for Atomic Diffusion Additive Manufacturing. Atomic diffusion, doesn't that sound fancy? Sounds like you're going to have a nuclear reactor in your shop, right? Not the case. What it really is, it's a combination of metal injection molding technology, which has been out for, to look it up, probably 50 years, and FDM 3D printing, which has been out, it's the first 3D printing ever invented. It's been out for at least 30 years. It's changed the game. It's a newer technology. It's only out for about 2 years. It's safer, it's more affordable, and it's easier to use than some of the other technologies that have been out there for some time. And how does it work? Well, it's a 3-step process. You print, you wash, and you sinter. If you were metal injection molding, you would mold, wash, and then sinter. So basically, it's the same process, but you're changing the first step from an expensive mold where you can only get one geometry to a printer which can print any geometry. So the printer is going to be every mold you ever wanted. You're printing in the same materials you would use in the mold, which is powdered metal, wax, and a polymer. And then after that, you're taking that part, what you call the green part, you are washing it in a solvent to dissolve the wax, and then you're sintering it in a sinter furnace, and then in the end, you get a metal part. None of the other ingredients are left. It's very similar to metal injection molded metal. So I wanted to share this very quick use case with you guys, just coming to the end here. Caldwell Manufacturing. These guys make windows and doors, components. You've probably heard of them. They're a pretty big company. These guys actually implemented both technologies I just talked about. They implemented ATOM and CFF to great benefit. They cut new product development time from 6 months to 6 weeks. Game changer, right? And part costs cut by 10 times what they were doing before. So really big benefits there. I really like these comments that are on the next slide because change is scary, right? The status quo is easy and everybody's comfortable, but sometimes you have to go ahead and take that leap. And that's what Caldwell did. So I want to just quickly cover these comments. So what would a president and CEO be scared of? Well, they're going to be scared that a new technology is not going to really be part of the culture of their company. So the president and CEO of Caldwell says, I think it has increased engagement and it's reduced turnover. It's part of our culture now. What would the director of engineering be scared of? Well, they'd be scared that they get a fancy new tool, but none of their engineers wind up using it. But the director of engineering at Caldwell says, my guys would tell you it's their go-to tool. As soon as they want something, they immediately think 3D print it, and then they're off and running. And what would a model maker of 36 years be scared of? Well, the learning curve, right? Oh, I got to learn this whole new technology. It's very advanced. But the model maker at Caldwell said, I was afraid that 3D printing would make my job harder. And I was going to have to learn a lot more different things. But in reality, it's changed for the better because now I can create a lot of things I couldn't create before. So they took the leap and it paid off. And Design Point, we want to help you guys in your additive journey. We want to help you along the way. So we hope that everyone signs up for our course with MassMEP. You connect with us through MassMEP, and we're able to help you out there. Thank you so much for your time. It was really fun sharing this stuff with you guys. It's really exciting. And with that, I will pass it back to Haley. Thank you so much.
Thank you, Andrew. We're gonna jump, we're running a little tight on time. So I know Nathan has this down pat though. He's pretty much, he is our resident Zoom presenter expert. So we're gonna jump right into Nathan. He is the automation engineer with Access New England. So Nathan, the floor is yours.
Great, thank you. Can everyone see can you see my screen? There's two screens on, you see the presentation? Perfect,
Yep.
okay, great. So let me just make sure I'm using the right one here. Okay, cool. So thanks again, everyone, for taking the time here, MassMEP, for putting this together. I remember the last time I presented one of these was several months ago. We were all together in Worcester at the DCU Center. A lot has changed in just 6 short months, but I appreciate the opportunity to get in front of some new folks and talk about what we at Access New England can do in terms of factory automation. So Haley, I don't know if you could throw the poll up here for me really quick, or did you already put it up? I didn't see it. I just wanted to get a quick, sense of it. Folks in the webinar here, if you've had a chance to automate in your factory, or if you'd like to, just to kind of drive my understanding of sort of the goals of some of the people who've attended this webinar. And obviously, feel free to reach out to me directly afterwards if there are any automation-related questions. But I work for Access New England. We're a local automation distributor based in Danvers, Massachusetts. There's our building on the left here. We've got 3 offices, basically our headquarters in Danvers. We've got our satellite facilities in Connecticut, in New Hampshire, and then we've got another manufacturing facility out in Rochester, New York. So we cover all New England. We've got about 20 engineers on staff. We're, I think, 55 people now. We just hired a couple more customer service folks to keep fielding those phone calls. We're very engineering focused. All of our salespeople, applications guys, all have engineering degrees, and our goal would be to anyone we interact with, engage with on an application, you're getting a subject matter expert who really understands the automation, the application, mechanical design, that sort of thing. And so we really want to take a holistic approach to helping our customers deploy automation. I'm just going to quickly take a step back here and talk about Industry 3.0 to contrast that with sort of our Industry 4.0 offerings. So everyone's probably familiar with factory automation, to some extent, CNC machines, water cutters, custom automation. That is a large part of our business, as you guys can see here on the screen. We do a lot of those, we work with a lot of those companies that make those custom pieces of equipment and provide them with servo motors or robotics or controls or HMIs, the kinds of components and system assembly solutions that go into that traditional automation. We've been doing it for 25 years. We're going to keep doing it. There's always going to be a place for that, especially with like semiconductor, life sciences, very specialized hardware. But more recently, we've had a number of emerging technologies kind of come onto the scene, the past 10 or so years. Robotics, industrial networking, mobile robotics are kind of the 3 areas that I want to talk about. And I would say that our emerging technologies fit well in line with the topic and idea here of Industry 4.0, right? So this takes the automation hardware and sort of connects it to each other and connects it to people, right? So now we've got robots talking to each other, machines communicating, and people working with robots, and everyone's sort of benefiting and augmenting what people can do. So these technologies that encompass that, at least the way we look at it, would be our collaborative robots, our autonomous mobile robots, and our industrial Internet of Things. So I'll touch on all three of these categories, and I will try to keep it brief because I know we're kind of crunched for time here. I'm going to start with industrial wireless. We had a great presentation from the guys at Machine Metrics. That's a good example of, we've got this ability to collect data on the factory floor. I'm sorry, I'm in the middle of the webinar. We've got this ability to collect data from the factory floor and push it up to the cloud. We've got all these robots networked throughout our factory floor that all need to be able to communicate with each other, and we need a strong, reliable way to keep that information flowing. And that starts at the factory network level, right? So we need to have strong networks. You can't just go to Staples and buy an access point and expect that that's going to work in your factory, where you've got, in your house, a lot of times, you turn the microwave on and now my Wi-Fi doesn't work, right? Now picture that in a factory where you've got hundreds of machines emitting magnetic radiation, big pieces of metal, all working. You need a specialized kind of network solution. So what we can do at Access New England is actually come in and survey your facility, monitor all the strengths and weaknesses, strong points, dead spots in your factory, and design a custom networking solution that's really meant for the rigors of an industrial environment, right? High temperature range, vibration, that sort of thing. So one example, we worked with a local medical device manufacturer that had a fleet of about 25 universal robots and 5 mobile robots in their factory. And they weren't having good luck with their traditional network, so getting the robots to communicate. Say you've got a guy on one side of the factory who orders the robot to come over and drive over to his side of the factory to pick up some parts and then drop it off at another area, right? You need to make sure that as soon as that button is pressed, the robots are able to communicate. And especially when you've got robots traveling at high speed, if you have a dropout, the robot might not know where it is. So we came in, we spent a day surveying the site. We came up with a case study, a plan of action, and we deployed a total network with 15 access points, a large fiber optic redundant ring. So if one side of the cable gets cut, we're still up. And we were able to do that in about 3 months for one of our customers. So I mentioned the mobile robots and I've mentioned the industrial arms. These mobile robots are really cool, right? So we've got a couple different technologies in this space, ranging from smaller, sort of 1 or 2 off type of mobile robots to large automated fork trucks. And really what these are and how they're different from maybe the AGVs you're familiar with is these no longer require modification of your factory floor, guide wires, special, magnetic tape in the floor. These are totally autonomous, drive around, kind of like a Roomba, but with safety rated communication, safety rated sensors. So this will navigate throughout your factory at a very basic level from point A to point B. We've got a number of ways to integrate these with your ERP systems, different inputs, operator push buttons, CNC machines, whatever your production workflow is, we can integrate with it and use this, mobile robot as basically the transporting of goods in your factory. We go up to, 1,500 kilograms, 3,000 pounds with the mobile robots, and then the fork trucks, we can go up to, 10,000 plus kgs, automatic, totally safe, really saving some of this non-value added work that a lot of times people have to do in factories. An example, a customer we did recently was a defense contractor here in Massachusetts, and all these examples are in Mass because I'm the sales guy for Massachusetts, but we recently did an application at a defense contractor where they're making this large radar assembly, and you need to assemble several different components, and they're very heavy, and they're moving from one side of a 1 million+ square foot factory to the other. So we deployed a couple of these MiR 200, the mobile industrial robots, in their factory to move parts from one side to the other. And so they integrated tightly with their ERP system, and it actually, goes and an operator finishes a job, they press a button, the robot comes over, they load it, and then it takes it to the other side of the factory. So those operators can focus on what they do versus pushing stuff around the factory. And then finally, the sort of the flagship product, in my opinion, is these collaborative robots, right? So this is a new type of robot. I'm sure some folks in the audience may have heard of collaborative robots before. Some folks may have not heard of collaborative robots. What it is it's a robot that is safe to work in a human environment, interact with the person, work right alongside them, right? So you've got, like in this picture here, a person and a robot collaborating to sort of get the strength of both, right? A person isn't always going to be great at sitting there and doing the same thing all day. A robot might not be as dynamic as a person. So we can really, deploy these throughout your tight factory in a flexible manner because these robots don't need safety guarding. That's essentially what collaborative means. And we partner with Universal Robots. They're the world leader in collaborative with over 45,000 robots deployed. At Access New England, we're coming up on our 1,000th robot. And if anyone in the audience wants to be that 1,000th customer, I would love that. I'll take you out to dinner, but we're getting close. And so it's been a really successful technology for us since 2012. We've been deploying these robots. So to kind of contrast that with the traditional robots, you've probably seen these in your factory where you've got a big cage. This is a welding robot, but maybe you've got a high-speed palletizing robot. It's all in a big guarded cage. It's locked out to people. They can't interact with it. It does one thing very well, very fast, right? That's what robots have traditionally done, building cars, 1 million cars a year, et cetera. But they're heavy, they're dangerous, they're tough to program. Oftentimes it's a huge process to get someone in to learn to work on your process, do an integration and deploy the robot, hundreds of thousands of dollars. And the time to deploy them is often, I've quoted, or I've seen customers quoted industrial robot systems with 16, 20 plus week lead times for the system. And it's a big undertaking. And if it only does one thing, that's fine. But if you've got different production that might change, it's not really a good fit. So this is where the collaborative robots and the universal robots specifically really shine. They don't need safety guarding, so you can put them anywhere in your factory. You don't need to design a complex work cell. And they're easy to program, so you can do it yourself. It's all touchscreen based. You show it what to do, you save the position, very straightforward. So you don't need to worry about hiring a programmer most of the time. You can do it yourself. And so what you get sort of at the intersection of these two benefits is you get a robot that's very flexible, has a low integration cost, and a very quick return on your investment. 6 months to a year is very typical for us, where you've got a robot that you can put to work a week from when you get it because it's easy to program, and you can change it over to do a new job. So it's not sitting there idle in just a couple of days or hours even. So it's very good from a return on investment standpoint. They're low cost, usually sub $100,000 systems. So some of the tasks that we focus on with collaborative robots, and think about this, 80-something% of you guys said, yes, we'd love to automate more in our factory. So think about some of these tasks just as an example of places that are good to start. Now, I will say Universal Robots has an app store that they've released where you've got hundreds of different tools that make plug and play automation possible for different applications, and it's growing on a weekly basis. So we're always adding new features of things that maybe you didn't think were possible before. I'll talk about some of those, but simple repetitive tasks like CNC machine tending is the gold standard bread and butter of this robot. Loading and unloading a CNC machine, doing assembly work, doing glue dispensing, clipping parts together, doing inspection, mounting tiny screws, those kinds of things that are hard for people to do thousands of times a day, robots are great at. Painting, gluing, and welding, process level tasks, including things like sanding and finishing as well, where you're doing a repetitive thing like dispensing a gasket adhesive or something. We've got tools that allow you to do that very easily. Automated keypad testing is something that we did recently. I just did an application at a customer that makes ventilators, and they need to calibrate the screens. So the person was pressing all these buttons on the screens, right? So we just showed them a robot with a force sensor, touch the button in a certain sequence, and they're able to actually, instead of doing a software QA test, they're able to automate the software QA and compare it with a physical touch on the screen. So now we're shipping more reliable ventilators. So that's pretty good right now. And I think that's the last one I wanted to do. Oh, and then things like palletizing, end of line assembly, packing, palletizing, sorting, transferring, those types of applications are very easy as well. And then I mentioned sanding. I've got a customer that does, they make countertops. And so these people are sanding Corian countertops all day. I've got customers that make radar assemblies, that they're sanding radar domes all day. That's the kind of job that's pretty tough on your shoulders and your arms. And from operator to operator, the force you're pressing down with can vary. Well, we've got ability to, with a robot, easily teach these sorts of crazy curvatures and apply a very constant force down on the surface and get a very good surface finish from the get-go. So just some ideas, things to think about, places to start. I'll give you a quick example. Another medical device manufacturer, if you guys are noticing a trend here, these guys had a challenging labor-intensive manufacturing process, loading CNC machines. The quality would vary between operators. So what they were able to do was deploy a universal robot. They're one of our first customers. 2012, we deployed this robot. And this particular robot's run over 8 million parts. And they've got over 10 robots now doing all kinds of different things, CNC tending, quality inspection. And they've got, a guy, you can see him in the picture here actually, who's sort of like their go-to CNC robot programmer guy. He's integrated tons of these things, and he's an in-house resource. So they're able to do it very affordably, which is great. My last slide here, or second to last slide, what we're offering with MassMEP is a 3-phase grant, part of the training process. I know there's other grants available. Tom could probably tell you more about some of these higher dollar value grants for full capital types of investments. But what we're offering to get people started is a 3-phase approach where I will visit your site, probably with one of my coworkers, one of my applications engineers, to look at applications, try to pick up a couple good candidates of, this is a good place to start. Let's start the automation journey here. Come back to our office with one of those candidates, maybe more, and do a proof of concept. So we're gonna maybe design a tool, do the whole, do some work to design and prove the whole process, get that process running, whether it's at our office or at your place, to show you that we can run a robot, automate your machine, and eliminate any doubt in your mind that maybe this isn't gonna work. And then we'll include either a full day of training at Access, if and when we're able to have visitors in our office and people are able to travel and meet people again, or a half-day training at your site, which we can do now. We'll wear our masks, of course. And so that way we're able to offer you the training as well as, putting aside any doubt that you can do this yourselves. And so that's paid for by the grant through the state of Massachusetts. That's what we worked out with Tom and the folks at MassMEP. I'm just going to close with this. We want to be your factory floor automation partner, your factory floor industry 4.0 partner. We offer accessible and easy to use technologies. Humans and robots can work together now. The robots do the mundane stuff. The humans do the engaging value-added tasks. Everybody wins. And we have the ability to augment your factory floor and enable smart communication in your factory floor from our wireless network solution. So this is my last slide. I'll kick it off to the next presenter, and I appreciate your time today.
Thank you, Nathan. We appreciate your time.
Oh, I saw some questions. I'll answer those
Yeah,
after.
Absolutely. There's actually the question in there specifically for you. So if you wouldn't mind going in there and
yeah, I'll message him right back.
Awesome. That's great. So we are going to jump into the most important part of this presentation. Sorry to everybody else. I know you did great content and everything, but Lisa Oden is with us today. We also have Jim Gusha, but Jim has, I guess he's gave the responsibility over to Lisa to do the presenting with us. She's we like to call her our resident Oprah. She likes to give things away to people. No, it won't be cars, but you may get some money out of this. So Lisa, the floor is yours.
Hey, thanks, Haley. I'm glad to be here with you today, and Jim is here with us as well, as you stated. And I know that I am what stands between everybody and lunch now, and only a couple minutes left. So I'm going to try to give you the cliff notes of participating in a consortium grant, which is how we would see the companies achieving the training that people were talking about here today. For those of you not familiar with a consortium grant, they are through the Workforce Training Fund, and they are a type of the general grant that Workforce Training Fund offers. But what happens is a bunch of small companies can band together around common needs, and so we would specifically be doing the Industry 4.0 concept in this grant to be able to take advantage of some training and workshops that they might not be able to do on a standalone basis. We've got a big history with these consortium grants. We have developed 27 consortium grants working with about 126 companies over the last 5 years. And some of the other things that are included there is we've worked with over 2,000 employees in those consortium grants. Impacts have been 19.4 million cost savings, 540 jobs created, and 34.8 million in increased sales for the companies that have participated in these grants. So it's a good deal. The benefits of participating in a consortium grant is that MassMEP develops and writes the grant. And that's a complex process with a lot of nuances, so we take that on. Then throughout the duration of the grant, we also do the related grant administration work. There's quarterly reporting that's involved and that kind of thing. The companies that get involved in the consortium grants also have often found that this has been a tremendous networking opportunity for them. This says training cost is minimal here on the slide, but that usually refers to when we're doing face-to-face trainings and might involve, you know, shared lunch costs or something like that. So there probably would be no training cost involved in this one. And financial impacts are some of those that you've heard the other presenters today already talk about. They're also listed here on the slide, so you can refer to those in the future if you choose. So what happens with the responsibilities? The participating companies would need to sign an intent to participate, which we'll make available to everybody, and then make a real commitment to the consortium training plan. You'd have to get a certificate of good standing to get things going right away. If you've got a union on board, you would need a letter of support from them. Selection of courses, this is the Industry 4.0 consortium that we're talking about, so it would be these courses specifically. You would commit to providing information and collaborating with the MassMEP grant developer to help complete the grant application, and also to providing the metrics for the quarterly reporting. And then 6 months to a year after the grant is completed to participating in the NIST MEP survey. Next. Thanks. Again, MassMEP takes the lead and does the grant administration, it coordinates all the schedules and facilitates the trainings, and also follows up with all the companies to make sure that, you know, this is going well for you and you're getting what you expected out of it. And the next slide, I believe, is just, we've already gone over this, that, you know, what would happen next is you would let us know and you would sign that letter of intent. You would identify your internal key contact, and we provided the link for getting your certificate of good standing to get started as well, just for easy reference. Here's all our contact information. I can go over this with anybody individually. You know, if this was, you know, too much of a Cliff Notes presentation, happy to do that in more detail with anybody. Thank you so much.
Thank you, Lisa. So we're going to leave you with the last slide. Thank you for everyone for sticking around a little bit longer than we had expected. We want to thank all of our presenters this morning. Everybody did a great job. The contact information that's on the screen right now, that's Jim and Lisa. I apologize, I didn't put Robin on here. I will do that for the next one. And also just a graphic image of the letter of intent. So it kind of gives you guys an idea of what it looks like. But we won't hold up any more of your time. We want to thank everyone for attending this morning, and we appreciate it. And please feel free to reach out to any of us at any time. If you have any further questions, the number's there and our website, and we will be happy to answer them. So thank you, participants, speakers, and we look forward to doing this again soon.
Thanks much. Have a great day.
Thank you.
Thanks, everybody. Come again.